Alright, this video is going to be a little conjugate review, just in case you guys forgot how to do these. So it's only going to be 2 examples so that it's pretty short. Sorry, that was a terrible square root. Alright, so let's say we have to simplify the problem, square root of 5 divided by 1 minus the square root of 3. So what we do is we multiply it by the conjugate, which is 1 plus square root 3 over 1 plus square root 3. So on the top, I just need to distribute the square root of 5 to each piece. And so square root of 5 times 1 is the square root of 5. Square root of 5 times the square root of 3 is the square root of 15. Then on the bottom, I need to FOIL those. And so I've got 1 times 1 is 1, plus square root 3, minus square root 3, and then it's minus because I have a negative times a positive, and the square root of 3 times the square root of 3 is the square root of 9, which is just 3. So you can think of it as root 3 times root 3 is root 9, which is just 3. Or you can think of it as root 3 times root 3. When I do that, the square roots cancel, and I just get 3. That's kind of written weird. But either way you think of it is fine. And so what happens is the middle 2 terms cancel out. This will always happen because the goal in rationalizing a denominator, that's what you're actually doing here, is rationalizing the denominator. And the goal in that is to get rid of the square root sign. So that will always happen. So this final answer is the square root of 5 plus the square root of 15 over negative 2. Now one thing you might notice is that if you look at your parentheses, 1 minus square root 3, 1 plus square root 3, it's kind of like the difference of squares. Like if you had factored the difference of squares, you would get 1 plus version of the parenthesis and 1 minus version. And so if you're like going backwards to what would have had that problem originally, then you just take the first term squared, that's the 1, and the second term squared, square root of 3 squared is just 3. And then it's got a minus in the sign in the middle because it's a difference of squares. So that's a good like shortcut way if you don't want to have to FOIL it every time. Alright, next example. Let's say we have 1 minus the square root of 5 divided by 2 plus the square root of 5. So this one we're going to multiply it by our conjugate again. 2 minus square root of 5, because we always just change the sign. So on this one I have to FOIL the top and the bottom. And so the top would be 2 times 1 is 2. 1 times negative square root 5 is negative 1 square root 5. Negative square root 5 times 2 is negative 2 square root 5. And then negative square root 5 times negative square root 5 is positive 5. And then I'll FOIL the bottom, and you can do what we just said about difference of squares, or you can FOIL it, it doesn't matter to me. 2 times 2 is 4. 2 times negative square root 5 is negative 2 square root 5. Square root 5 times positive 2 is positive 2 square root 5. And then positive square root 5 times negative square root 5 is minus 5. And these cancel always. And so on the top, if I combine my like terms, I have a 2 and a 5, and I get 7. And then I have minus 3 square roots of 5. And all of that is going to be divided by negative 1. And I can simplify that, so that'd be negative 7 plus 3 square roots of 5. Okay, one last example to make sure we're good. You can shut off the video if you want, if you've got it already, but if you need to see just one more. The conjugate here would be 3 plus square root 3. And again, we're going to FOIL the top. So 2 times 3 is 6, plus 2 square roots of 3, plus 3 square roots of 3, plus 3. And then we'll FOIL the bottom. 9 plus 3 square roots of 3 minus 3 square roots of 3 minus 3. So on the top we have 9 plus 5 square roots of 3 divided by 6. And so far we haven't had one that could simplify, but if you were looking at these coefficients all in here, and all those numbers were divisible by the same number, then you would divide if you could. to simplify the problem, but it doesn't always work out like that.